Welcome to Module 4 of Intro to Operating Systems. I'm your professor, Professor Fiske. And in this micro lecture, we're going to discuss staying protected with Windows security. Like how do you stop nefarious and malicious actors from accessing your PC? Or accessing your servers? Accessing the resources that you use to commercialize your business level offerings. Well, there's a couple ways to do it. Oh, that got loud, didn't it? There's a couple ways to do this. And the first way that, I would look into doing this is using what's built in with the operating system. And what's built in with the operating system, specifically with Windows 10, is your Windows Defender. This includes Windows Firewall, which I have Windows 11, so if I showed you Windows, I guess I could show you Windows 10, the Windows 10 Firewall, or the old school firewall with Defender and Advanced Security. So this actually predates Windows 10. And I can't make it bigger. I do apologize. At least I don't know how. But in here, we can have specific rules that allow us to prevent access to this PC over specific ports. More specifically, when I say the word port, I mean ports with respect to our TCP/IP address. Your TCP/IP address, or in short, your IP address, is not just 1 or 4 octets, right? Your IP address is a lot more detailed than that. What is your IP address? Well, your IP address is the way that it's your address on the network that your PC is connected to. If your PC is not connected to the internet at any way, shape, form, or fashion, or connected via its network interface card with a cable or your Wi-Fi, then in that situation you will find that your PC is not connected to the internet or network, and therefore it has no IP address. That's not necessarily true. What essentially happens when your PC is not connected to the internet or to a network specifically, your specific device is given what's called an APIPA address. And that APIPA address is normally 169.172.x.x, whatever those two x's are. And it's between a specific range, which basically states to us as engineers that I know this PC is off the network. Now, an APIPA address, an APIPA address is specifically used for when the PC wants to communicate to itself, because it knows that there's nothing else that it can communicate with on that specific network that it's not connected to. And I don't want to go too deep into this, because this is a networking way of explaining why we turn on security. Security is normally between OSI layers 1 through 3. When we look at the OSI model, from an old school perspective, OSI model, and then we looked at the OSI model, Geeks for Geeks. The OSI model gives us a very simple way of understanding how our network stack or our computer stack works. Now, I'm not going to go too deep into these, but this is important for this specific micro lecture. The physical layer is a layer that we start with, and that's the bottom layer. Normally, the physical layer is the layer that's connected to your hardware, right? So your PC or laptop is connected via an Ethernet cable to a Ethernet port of some kind. Or if it's Wi-Fi, that network interface card in your laptop and or PC is connected to the network via that specific adapter. The data link layer is when we abstract ourselves away from our PCs and our laptops, and we are now at the switch layer. The data link layer is where the switches reside, and normally your switch is where a lot of your devices are initially plugged into, unless you have a hub of some kind. But those are not necessarily known to be data link layer, because switches are not stupid. Now, when I say the word stupid or dumb, I don't mean in the context of how we define human intelligence. When we call a switch dumb, we mean that switch is not thinking for itself. It doesn't have the ability to determine or to communicate with anything on the network. Now, this is very telling, because when you really think about the data link layer is where a lot of the initial networking happens, and the data link layer is normally truncated into specific domains by your switch. The switch is normally where, and people can correct me if I'm wrong, but switches are normally where your initial ARP tables exist, which allow the switch to determine who is on the network that it is currently administrating. One step up from the network or from the data link layer is your network layer, and that network layer is divided. The broadcast domain of the network layer is divided by your modem, or more specifically, your router. I didn't mean to say modem. I apologize. Your router, in and of itself, is the last bastion of network gateway. If you want to think about it that way, because network gateway is a thing, right? So if you went into your your NIC card, I just said card twice, but if I went into my network interface card, so network connections, I think is where I want to be, and here we go. So I'm in my network interface cards, and if I went into my Wi-Fi, which I'm not using, I should be able to go to properties, and then when I go to properties, I can click on the IPv version 4, Internet Protocol version 4. That's the one that normally is used at your PC level when you're on a home network and as you connect to the internet via your router and or modem. Once your device leaves your router and or modem, it then uses a series of other addresses which also transform into an IPv6 address until it reaches back into another network that uses IPv4. That's a long story. I don't want to get into that. But all I want to say is if you want to see what IP address you are actually using, you go to properties and it would show you. Now in this case, if you want to zoom in your screen, you'll find that I have my IP address being automatically determined by my router. My router is, or switch if I'm connected to one, determines the IP address I'm allowed to use because my router normally has what's called a DHCP pool assigned to it. DHCP is the way we can dynamically assign IP addresses from a specific network pool of IP addresses that are allowed for when someone connects to that specific port and or switch or modem. So what's DNS? Well, DNS is what's called domain name service, and your domain name service allows for IP addresses to be converted or translated, I should say, into regular names. So www.google.com can be is translated into a specific IP address. And for those of you who want to know what that is, Google.com has multiple IP addresses, and Google.com acts as the root to the internet, just like the DoD or the government does, NSA and whatnot. If you ever wanted to map to a root DNS server without automatically allowing your router and or server, because you can have a server that's DHCP enabled, having those servers available to offer you a DNS address, then what you would need to do is you would need to find one that's suitable for you. In this case, the Google DNS server is 8.8.8.8. So if I went into terminal, because I'm in, once again, I'm in Windows 11. In Windows 10, it would be called command prompt. So for the sake of this conversation, I'll use command prompt in administrator mode. Yes, and I'll bring it over. I won't change my directory, so no CD or anything like that. We're just gonna say ns lookup. So this is namespace lookup. Enter. Now that I'm looking up. Now notice that address right there. That's a IPv6 address, right? This is what this is. And normally you get an IPv6 address from internet-based devices that are serving multiple devices from the public internet, okay? But in this case, what I want to do, and you can see I'm using Spectrum, but in this case, what I want to do is I want to show you how you can find out what Google's IP address is. So I'll type in www, very important, you type in the entire fully qualified domain name, www.google.com, you don't need HTTPS or HTTP, and it will tell you. Notice those IP addresses look very interesting, because the IP address that we were just given is an IPv6 address, which is that 206:F8B. Now, you might be thinking, wow, that looks like gibberish in comparison to the 142.251.35.228. And you would be correct, because this one below it is the IPv4 address. The one above it is the IPv6 address. Now, these addresses have the ability to allow up to 25,000 plus different connections using that address to the same device. I'm going to say that again. there are about 25,000 plus ports, we call them ports, that are promoted by each IP address that is on a device. Now, this is important because if I wanted to know what is communicating with me, I would need to know what IP address port I am being, or what TCP port, more specifically, they are speaking to me in. So IP address is the actual residence of your device. Now, if you want to know your IP address on the actual World Wide Web, your public IP address, not 1.2.168, that's your private address to your local PC on your local device. But if you wanted to know what your public address was, you would go to whatismyip.com. All right? You go to whatsmyip.com and it will tell you the IP address. I'm not going to press enter because I don't want to reset my modem. You go to whatsmyipaddress.com, it will tell you what your IPv6 address is to your modem and what your IPv4 address to your modem is, because your internal private network is being NATed out. Once again, I'm not going to explain this because this is going into networking. And once again, if you do deal with operating systems and administrating systems, you're going to need to know all this stuff. But I don't want to get into it because this is more networking than operating systems. I want to get into the port side of it so you understand Windows security, or security from a device perspective, right? So what's my IP address will tell you your public IP so you can address or lock down your ports accordingly. But what are IP ports? What are TCP ports? Well, TCP ports are ports which specific protocols are allowed to communicate over. So for instance, port 25 is SMTP. Port 7 is Echo. And if I opened up this one, this is a good one right here, you can see all of the ports that different, and I'm going to make it bigger so you can see it, all of the ports that different protocols are allowed to communicate over. So time and date communicates over port 13. MSP is port 18. FTP is port 21, Secure Shell is port 22, Telnet is port number 23. These are actually ones that, if you are a systems engineer, you would know these by heart, because these are the ones that you would need to lock down specific to the things that you would like to access to devices or servers that you have available to on your network. Now, time's getting a little, we're going a little deep into this, but I want to go deeper to show you one more thing, okay? So let's pick on DNS, because DNS is a fairly new phenomenon over the last 20 years. And I say new because computers have been around for about 70 years. But DNS is fairly new because up until this point, this is where I was going with Google.com. Up until this point, Google.com, all right, has always been Google.com, but the PC doesn't know what Google.com actually is. The PC only knows what the IP address is. So when you put in google.com up here at the top, right, what's essentially happening is your browser is now going out through the network interface card and requesting the actual IP address of that location, and then using that IP address to resolve the name so that you can go where you need to go. If you in your Windows firewall lock this down and you did not allow communication through port 53, then you would need to use what's called a hosts file. If you wanted to look in your PC for a hosts file, HOSTS, it's in your system/Windows 32 folder. And your host file is your backup file. It's the legacy way we used to determine what names we wanted in our what's resolved. And I wonder if I'm going to the right place, so bear with me. No, it's not the right place. Host file is, I always forget where this is because I don't use it until I need to use it. It is under drivers. I was right. Yeah, drivers etc. Okay, drivers etc. And then here it is, host file. If you have Windows, or if you have Notepad++, if you don't have Notepad++, you should install it. Notepad++ is a wonderful tool for things like this. But either way, I want to click on it and then right-click on it so I can get to the edit with Notepad++ and open it. Now on my local host file, you'll see some things that are pretty cool, right? The first thing you'll see is that I have a Acme example here. What the host file does is it takes the actual IP address and it resolves it to the actual name. Now notice if you went to your system / Windows 32 / drivers / etc folder and opened up your host file in Notepad or Notepad++. Every device has what's called a loopback. This loopback allows you to communicate with your own device via the network interface card that you have. Now, why would I ever want to do this? You're like, well, why would I ever want to just communicate with myself? Well, what if I wanted to host a website and I wanted to verify that that website was working the way it was supposed to? I can go inside the Windows browser. I can go inside the browser right here, and I can type in localhost. And theoretically, what this should do is this should take me to my internal IIS server on my computer to the website that is mapped to. I don't have one on right now, so this isn't going to work, but that's how that works. But what is Windows security and how does it work? Well, if I go into Windows Firewall again, there's a couple of things here that we talked about, right? We spoke about the firewall, and we didn't speak about the levels, but there are different levels that the firewall actually works at. So we spoke about the OSI layer 1 through 3. We didn't go any further than that because right now we're just talking about the operating system's ports, right? So at what level is this operating? Well, it's between 1 and 3, depending on how you want to perceive it. You can have a firewall on your router. You can have a firewall between your router and your You can have a firewall on your switch. You can have a firewall between your switch and your device. And you can have a firewall on your device. Firewalls are just fancy ways of saying a gate. That's it. And there are certain firewalls that allow you to do certain things. Most firewalls, and the best practice of firewalls, and if I say this incorrectly, I do apologize because I know the terminology of this has changed. But if I wanted to ensure that I only allowed the IP addresses and ports through that I wanted, I would whitelist the things that I want. Now, I would whitelist the things that I want because the things that I want need to be allowed. There is the other direction. There's the opposite approach where I don't want to only deny all and then give the addresses that I want. I want to leave it open, so allow all, right? And then just blacklist the things I don't want or deny the IP addresses and the ports I don't want. There are certain ports you don't want on. Now you might be thinking, what ports are those? Well, if you're not using Exchange externally, then or if you don't allow external email traffic, then you would turn off SMTP, IMAP, and POP3. If you want to ensure that no one can telnet into your devices all willy-nilly, whether they're on the network or not, you would deny secure shell and telnet. Those are the ports that you would turn off pretty much all the time anyway, but that goes without saying. And then those rules are quantified here. Now notice I have specific rules for my device based on the things I have installed. Spotify Music, Teams, those jump out, VMware. But then there's other things that are like, what the hell is Microsoft Link? That's old school stuff. I thought they got rid of that a long time ago, but apparently they didn't. There's Outlook, right? There's cast to device streaming service. There's so much. But in the end, your inbound rules say, I allow this to happen. So look here, 53. Remember what 53 was? That was your domain name service. That's very important. So we need to allow that into our network, right? And from the perspective of allowing it into our network, there are two things that I'm allowing. There's TCP and UDP. So let's talk about that for a second, and then we're going to stop. TCP is a synchronous handshake between the device that you're trying to communicate with, or the server you're trying to communicate with, and your device. The way that happens is as such. Your device sends a request and says, hi, I am device A, or I am Francis's device. All right, that is called SYN, S-Y-N. The device that is on the other side is going to respond if it receives that message, if it's allowed to. And it will say, hey, yeah, you know what, device A? I'm device B. That's SYNAC, S-Y-N-A-C, or that's ACK, right? So there's SYN, there's ACK, acknowledge. I acknowledge you sent me something. And then you, again, your device, sends the SYNAC to say, now I acknowledge that you acknowledged. Let's communicate. And then you chat. Now, what I would argue makes sense for TCP as an analogy is using your phone to call someone. You call them and you're like, hey, I'm Francis. And they'll say, hey, I'm John. They say, great, John, let's have a conversation. That's SYNAC. We do it so fast we don't think about it. Now, within the context of this specific implementation, right, what is UDP? Well, UDP is a little different than TCP because UDP just throws the message to the other device and it does not wait for a response. So you can think about it this way. TCP is synchronous, and as long as that synchronous line is open and the handshake has been made, and sometimes that handshake is made over and over again to make sure that it's the same device I want to talk to, then everything's great. UDP is a little different, and we do use UDP a lot in engineering, where we just send the message and we don't wait for a reply. There are certain situations where we do this because we just don't want to wait for a reply. There's other situations where we do this because we don't care. You know, if you get it, you get it. If you don't, I'm going to send it again in 2 minutes, so don't worry about it. Now, in certain situations, you might be thinking, well, when would you ever do that? When I have a heartbeat. So let's say I'm checking another system. Let's say you have 2 servers in the same cluster, and one server is checking the other cluster to see if it's alive. Hey, are you still alive? Yes, I'm still alive. Great. Sometimes when you send that message, you're not going to wait for a reply because you sent it. It's like putting it in the mail. Great. I'll get it when I get it, right? Or sending an email. I'll get it when I get it. If I don't get a response, what am I going to do? Well, I'm going to send another one to see if you got the first one. Now, what's great about a cluster is when you have a server sending a request to another server saying, hey, are you still alive? And that other server does not respond within a certain amount of time, then the cluster has a quorum and it communicates with all the other servers in the cluster and says, hey, server whatchamacallit's not responding. Let's take that cluster out of the rotation and let's put somebody else in the rotation that is responding. Now, it might not be that server's fault. It might be the fact that that server is connected to a network that's not that great, that you're communicating with that over a slow WAN connection. Maybe the geographical distance between those servers is so great that it just takes a long time for that message to go back and forth or for the first server to get it and respond in a certain amount of time. You might be thinking, a long time? What are we doing, like years? No. A long time would be 15 seconds, 10 seconds, 20 seconds. That's a long time. If you haven't responded to me in 20 seconds, then I'm going to send another request. And normally we have like a 300-second buffer to say, okay, after 300 seconds, if you don't receive a response from that server, then assume that server is just not operating the way it should and put another server as the primary. Now, this could be an issue if you have the cluster always deciding to move the server because you have slow WAN connections. Slow WAN, wide area network, is a fancy way of saying you're communicating over the internet or over encrypted channels through the internet. All right, so we've already been speaking for 22 minutes. That's a long time. I want to stop here and say, please hit that like and subscribe button if you like this content. And as I say in all my videos, good luck, have fun, ciao.